Hello and welcome to our first section of Chapter 1. Well, technically our third section. If you want to check out sections 1 and 2, I do recommend them. There's a lot of good stuff in there, but we're a little short on time, so we're just going to skip over those ones. We're going to take a look at section 3. So we're going to be looking at different methods of solving quadratic equations. I'll fit this to width. So we're going to be looking at factoring, the square root method, the quadratic formula. Completing the square and graphing are good solving methods as well, but they're just sort of backups, and I'm not going to go into too much detail about those. Something I would like to note is that if you have a linear equation, so that's any equation that just has a regular old x in it. So if you've got an x, you'll get a single variable degree 1, you just get one variable by itself. If you just have that x, you're just trying to get the x by itself. If you have a quadratic equation, you have some variable of degree 2. So that's like this x squared thing. What we need to do is get that whole thing equal to 0. If you have a quadratic, you always want to get that thing equal to 0 in order to be able to solve it properly. Okay, there are some cheats, there's some shortcuts, but for the most part, like 95% of the time, you want to try to get that thing equal to 0. To do that, though, we do need to factor. Quick reminder about factoring, you're always checking this number on the end, that +2. So you want to say, okay, well, what multiplies to be positive 2 and adds to be 3? So we get 2 and 1, a -2 and a -1 because we want that -3. What multiplies to be 5 and subtracts to be 4? -5 and +1 will get us -4, and they multiply to be -5. Now that we do that factoring thing, we can do this zero product property. If you've got two things that multiply together to be 0, then somebody's got to be 0. Either the first thing is 0 or the other thing is 0. That's the only way that we can multiply numbers together to get 0. And that's going to be our trick for solving these quadratics, is we're going to look at that equation right there and we're going to say, okay, well, we want to set that thing up so that it is two things that are multiplied together. And the best way to do that is to just factor the thing. So I've got x and x here. Again, I want to multiply to be 2. So the only option is 2 and 1. We've got a plus on the end, and the way I like to think about it, if you got 3 terms and a plus in the back, this middle sign doubles up like a Wendy's double stack. It works out the same way as we had before. Then we want to look at those two things. We want to say, okay, well, what would make this thing 0? Well, x being 2, that would make that thing 0. So that's our first solution. The other one is what would make this thing 0? Well, x being 1, that would be our second solution. I've got a little typo here. This should be an x. Now, this one, it doesn't equal 0. And if the thing doesn't equal 0, then we can't solve the thing properly. So we need to get this thing to equal 0 first. So I'm going to bring everything over to the squared side. I like stuff with the squared side since my factoring is a little bit easier that way. So I'm going to bring everybody over to the 9x squared. Okay. And then I need to factor this thing. So I'm looking at that 9. So I'm going to probably break that 9 into a 3 and a 3. I'm just going to do guess and check method here. So a 3 and a 3. And that's 16. And again, I'm just kind of guessing here. So maybe a 4 and a 4. It's easiest to do factors that are right in the middle. All right, so then the 3x and the 4 would get me 12, and the 3x and the 4 would give me -24. Oh, sweet, I lucked out. If that hadn't have worked, I would have swapped out maybe the 4s with a 2 and an 8, or I could make the 3s a 9 and a 1. There's lots of things I could try. I've got 3 terms and a plus in the back. The center sign doubles up again, like a Wendy's double stack. So when we find the things that get this equal to 0, we get 4/3 and 4/3. So it seems like we really only have one solution, but it's just kind of like showing up twice. So our answer to this thing is just 4/3. Like there's no reason to write it 2 times. We would just write it once. Here's some other examples over there for you if you want to check those out. Now the square root method, something to keep in mind is if we square root 16, all we get is 4. However, we are allowed to, this is one place where you don't have to get the thing equal to 0. We are allowed to square root both sides, but when we do that, we get plus or minus 4. And now the reason that we would do that is if you would alternatively work with this thing and factor it and do that proper thing of getting the thing equal to 0, we would factor this as an x plus 4 and an x minus 4, which gets us that same x equals plus or minus 4. So we need to make sure that the orange method and the purple method get us the same thing. An alternative way to think about this is if you're squaring something and it gets a 16, just use your intuition. Like 4 squared, that's 16, but negative 4 squared is also 16. So we want to make sure we're using both of those solutions. I can't stress enough how important it is to get this plus or minus. In geometry, we always use the positive one. In algebra, we told you to use both. In pre-calculus, we're going to mix it up. There's going to be times where we just want the positive one. There's going to be times where we want both. And there's going to be times where we just want the negative one. So it's important that we know that that plus or minus exists. And then we look at the context of our problem to determine which one we're going to need. So if I was working with some of these problems, I've got that x squared plus 64. Now I can't factor that thing, but I can use the square root method on it. I can get the x squared by itself and then square root both sides. So I get x equals plus or minus the square root of negative 64. And hopefully we remember from advanced algebra, but if we square root a negative number, we get an I for an imaginary solution. Square root of 64, that's 8. So we get plus or minus 8i. Now we can do something similar even if there's a parentheses there. We can square root both sides. So we get 1 minus x equals plus or minus 3. Then we can bring the 1 to the other side. Or actually, I'm going to bring the x. No, I'm going to bring the 1 to the other side. Sorry. Can't make up my mind. So we get negative x equals negative 1 plus or minus 3. Divide both sides by negative 1. We get negative 1 plus or minus 3 over negative 1. Now we should evaluate this out. We should not just leave that. We can do that. Negative 1 plus 3, that's 2, divided by negative 1, that's negative 2. Negative 1 minus 3, that's negative 4, divided by negative 1 is 4. So x equals negative 2 and x equals 4. If you can simplify something that looks like that, simplify it. Don't leave it alone. I can't tell you, this annoys me. Like people just leave that and I'm just like, come on, you know what that is. Or they'll leave that like 2 plus or minus 4. I'm like, you can't add 2 and 4 together? Come on, come on. All right, last method that I got to show you is the quadratic formula. If you do not have this thing memorized at this point, get it memorized. X equals opposite b plus or minus the square root of b squared minus 4ac all over 2a. You got to get that thing memorized. I've got a video of like a 5-year-old who's got it memorized, so you can get it memorized too. So I need to use the quadratic formula in this one. And the way I know is I try to do a factoring. Something that multiplies to be 9 and adds to be 2. Well, 3 and 3, they don't make 2. And 9 and 1, they also don't make 2. So since I don't have any factors of 9 that add to be 2, I know I need to use the quadratic formula. I always recommend trying to factor first because factoring is always going to be the faster method. So we get x equals opposite our b value, which is negative 2. In this case, reminder, it goes a, b, and then c, plus or minus the square root of b squared. Well, I know that it's 4 minus 4 times my a value, which is 1, my c value, which is 9, all over 2 times our a value, which is 1. I do a little bit of simplification. I take care of everything that's inside of that square root first. So I get 2 plus or minus the square root of, let's see, that's 4 minus 36. So that's negative 32 over 2 times 1, that's 2. Make sure that line stays nice and long. All right, so the square root of 32, I'm going to break this thing up. I'm going to break this up into a square root of negative 1. So I've got a negative. And then I want to break up that 32 into a perfect square and a non-perfect square. So 16 and 2. 16 times 2 is 32. 16 is a perfect square and 2 is not. So I've got an imaginary piece, I've got a perfect square piece, and I've got leftover garbage. So this works out to be square root of 16 is 4, but I'm going to write the 2 plus or minus first. And then square root of 2. All over 2. Now I am allowed to do a little bit of canceling. Imagine if I had factored out a 2 from that numerator. 2, 1 plus or minus 2i square roots of 2. Now I've got everything else nice and wrapped up. That 2 is also wrapped up. Whoop, whoop, and I'm able to cancel it with that 2 in the denominator. So our final answer for this thing is just this piece, because I can cancel this 2 and that 2. 1 plus or minus 2i square roots of 2. And that is done. There's some additional examples on here if you want to check them out. Good practice for all that stuff. If you want to check out completing the square, check out page 118 of your text. Completing the square is a really cool thing. We don't need it until the end of the year, so I'm not going to talk about it now because I'll just have to reteach it again at the end of the year. Graphing is also cool. If you use your graphing calculator, you can check the x-intercepts, and that'll also tell you the solutions of your equation. That's it for solving. Thanks for watching.